This is our review for Module 17, adding and subtracting polynomials. For number 1, they want us to solve this equation and find the value of x. Well, what I notice is 16 and 2 are different bases, and I can't solve this problem until I have the bases the same. So I'm going to rewrite 16 as 2 to the 4th power because that's the same as 16. So in this first equation, I replaced 16 with 2 to the 4th power, and I still take that quantity and raise it to the x plus 3. Well, recall when we have a power raised to a power, that's when we multiply. So it becomes 2 to the 4x plus 12 equals 2 to the x minus 3. Now that the bases are the same, we realize that their exponents can be equal. So 4x plus 12 equals x minus 3. I'll subtract x to both sides and get 3x plus 12 equals negative 3. I'll subtract 12 to both sides. 3x equals negative 15, and so I know that x is equal to negative 5. Number 2, what is that expression evaluated for x equals negative 3? It's just a matter of substituting in those numbers. So I've substituted, and I'll evaluate inside my parentheses first. And I've got 5 times positive 9. A negative 9 times a negative 3 is a 27. We're now adding 27. So this amount right here is 45. When I add 45 to 27 and I multiply by 3, I get 216. For number 3, we're going to find out if the given expression, if the comments on it are true or false. So we've got 4xy to the second z, and they're asking if it's a binomial. Yes, it's just got one term. It has lots of factors, but it's one term. The expression has a degree of 2. I see that exponent of 2, but don't forget about the understood exponents here of 1 and 1. The degree here is really 4, so the 2 answer is false. The expression has a coefficient of 4. Yes, it does. That's the 4. Number 4, what is the degree of that given expression? So I see a third power here. I see a 2, 3, and a understood 1 here. Obviously, I've got higher exponents over here. I add them up. 2 plus 3 plus 1 is 6. This is of the 6th degree. Number 5, is each of the following a cubic binomial? So binomial means we have two terms, and cubic means it's of the 3rd degree. So this is a binomial, has two terms, and it's of the 3rd degree. That's a yes. This is a binomial, but it's of the 2nd degree. So that's no. This is a binomial, and it's of the 3rd degree. It's yes. This is a trinomial. Also, it's of the 4th degree. It's no for every reason possible. Number 6, which of the following is correct classification of this expression? Is it a binomial with a degree of 3? No. Is it a binomial with a degree of 2? No. Trinomial with a degree of 3? Well, it's a trinomial, but the degree is not 3. I see a 3. Those add up to 5. It's the highest amount. The choice is D. On number 7, we're going to simplify the expression, and I see I have like terms here. Remember, for something to be a like term, the base has to be the same and the exponents. There's an understood 1, so they combine to be 6m n to the 2nd power minus 8m. Number 8, find the sum of those two expressions. So again, we're looking for like terms. We have a like term here. Those give us 12x cubed. For my x's, they combine to be minus 3x, and finally that plus 4 at the end. Number 9, we're going to now subtract. Remember, we like to turn subtraction into addition of the opposite for everything after the new addition sign. So now let's combine. So 2x squared plus negative 7x squared is minus 5x squared. Minus 5x is all by itself. Negative 7 plus negative 3 is negative 10. On number 10, we've got a rectangle with a width of W, and its length is 2 units shorter than 3 times the width. So 3 times the width is 3W, but it's 2 units shorter. And if, of course, this dimension is that, then we have that over here. And if the top is W, then the bottom is W. That's the nature of a rectangle. And if I were to add these all up, and don't forget, W is really 1W, I'm going to get 8W minus 4 if I simplify. And we are talking about the perimeter of this rectangle. So which of these expressions is equivalent when we simplify to 8W minus 4? Well, 2W plus 3W plus 3W is 8W, and we do have a minus 4, so that one works. This next one doesn't. There is no squaring. 8W minus 4, yup, that's what we got exactly. And on this last one, it doesn't have the minus 4, so that's a no. All right, number 11. The amount Thomas makes in dollars working 8 hours is this expression right here. And he hopes to get a raise that will increase his pay by that much, right? The expression to represent how much he's going to make. So we're just adding those two. Well, 18H plus 2H is 20H, and 8 plus 32 is 40, and that represents how much he'll make with that raise. And I think I've got something cut off here. We've got to find out, hey, how much is he going to make in 8 hours? So that's 20 times 8 plus 40. That's 160 plus 40, and he's going to make $200. And number 12, this is review from last unit. And what I like about this is I don't think we ever did one like this with a negative exponent, although it does not make things particularly difficult. So let's just make a table of values. For x, our exponent, let's choose -2, -1, 0, 1. I actually had started off doing this problem with just my -1, and I didn't have my -2, and I realized I could use a few more values. So when my exponent is a -2, I've got 2 raised to the -2, which is really 2 squared, and I get 4. The next one, when I do 2 raised to the -1, well, that's really 2 to the first power, which is 2. And 2 to the -0 power, well, 0 and -0 are the same thing. Anything raised to the 0 power is 1. And on the last one, when I've got 2 and I plug in my +1, but don't forget there's the negative sign there. When I have a negative exponent, that's just a fancy way of saying that I'm in the wrong half of the fraction. So I rewrite it, and it becomes 1/2. And for good measure, we could do, if we plugged in a 2, that would be 2 to the -2. Once again, it's in the wrong half of the fraction, so I just rewrite it as 1/2 to the +2, but we just know that's 1/4. So let's go plot those. You might notice that it's going to be backwards. I missed a value. Oh, there we go. And we can plug these in. When x is -2, y is up at 4. When x is -1, we're at 2. When we plug in a 0 for x, we get a 1. When we plug in 1, we get 1/2 and 1/4, and I can see that I am approaching 0. And that's my graph. Number 13, identify each expression as a monomial, polynomial, or neither, then classify the polynomial by its number of terms and its degree. Found these directions a little odd. I could just see skipping and classifying it by its number of terms, but I guess we want to identify those things that, hey, they're not polynomials at all. So the first one is, yes, a poly. In fact, it has 3 terms, so we would call that a trinomial. Okay, so I've answered this and that, and now we're going to classify it by its degree. Well, that one's kind of easy. It's of the 4th degree. Now this next one is neither. It is not a polynomial, and here's why. You could look at it in one of 2 ways. We can't have our variable in the denominator, or if I were to rewrite that, I could call it 5 times t to the negative 3. So either we'd say we can't have a variable in the denominator, or we can't have negative exponents. Either way, it's not a polynomial. So on C, well, this appears to be a polynomial. I see 2 terms, so we would call that a binomial. Don't forget that the r and the s each have an understood exponent of 1, so we would say it's of the second degree. We have a fancy name for that. You might have seen in the answer key that that's called quadratic. So you should know that quadratic means it's of the second degree. And I think I've answered all of that one. Okay, number 14. They want us to write this in standard form. And actually, I see a little of module 18 in this problem, but I don't think that's going to bother you. You realize I could distribute this. That's the part that is module 18. No worries. 8x times x squared is 8x to the third power. And 8x times 1 is 8x minus 12x squared. But I'm not simplified yet, so I guess that's not my final answer. Well, it is, there's no like terms to collect, but I'm not in standard form yet. I have to put things in order of degree. So my final answer is 8x to the third, 8x to the third minus 12x squared plus 8x. Right, on number 15, we're going to simplify. Well, this is just an addition problem, and we have to look for like terms. Remember, like terms have the same base with the same exponent. So I can add those two right up and get 14x squared. So they're done. Now, do I have any other xy's? I don't, so he stands alone, plus 21 xy. Okay, here's some y squareds. I could combine those. Negative 7y squared plus 11y squared is 4y squared. And finally, that minus 20. That is in standard form, and it is simplified. All right, number 16, the area of the composite figures are labeled below. So these are all the areas, and they just want to find the simplest form that represents the total area. So this is just an addition problem. So all of my x squareds combine to be 3 halves x squared, if I were to call that 2 halves. My x values add up to 7x, and my constants combine to be 6. And that represents the area of the total figure, all added up. Find the area of the figure if x is 6. So let's just go back up and plug in 6. Now I could plug it in here, or I could plug it in there. Actually, when I did the problem, I plugged in my 6 over here. But I could do it here. That was what was intended. So 3 halves, if I plug in 6, 6 squared is 36. 3 halves times 36 plus 7 times 6 is 42 plus 6, and 3 halves of 36, 48 plus 42 plus 6, and I got a total amount of 102, and they told us that's meters, and this is area, so I would say meters squared. Don't forget your units. Your science teacher will love you. All right, so now we're going to read the directions carefully. It says find the opposite of this by simplifying this expression. They want us to simplify. So what we're doing is we are multiplying the entire thing through by -1. So we get a negative 7x squared plus 5x. They asked us to find the opposite, and that's what we did. On number 18, so number 17 was a baby step for number 18. They want us to simplify. And once again, once I get to this minus sign, I'd like to add the opposite. Now I can combine my like terms. 32mn squared minus 10mn squared is 22mn squared. Those two are done. Now I've got 50m squared n plus 16m squared n, and I get 66m squared n, and finally minus 64. Let me check my answer key. Yep. Number 19, the last one, a company's cost in dollars in making X tablet computers can be represented by this. And those are the, what do we say, costs? Yep. And the revenue from selling the tablets is this. And they want us to write an expression to find the profit. Well, profit takes your revenue and subtracts out your costs. So we're just subtracting 30x plus 50 minus 25x plus 150. But I do like to turn subtraction into addition of the opposite. And when I combine those, I get 5x minus 100. It looks like they only make $5 per tablet. Not enough profit in my opinion. All right, so that's the answer to the first part. And I think in the second part, they wanted us to find how much they're going to make if they create 150 computers. So this is the answer to the first part. And for the second part, you use that and plug in your 150 computers. Don't forget to subtract the 100. When I did, I came up with a profit of $650.